Okay, Assalamualaikum warahmatullahi taala wabarakatuh dan salam sejahtera. So welcome back to Universiti Malaysia Terengganu from me, Dr. Hakim Cik Harun, and today I teach at Universiti Malaysia Terengganu Faculty of Ocean Engineering Technology and Informatics. Welcome back to the session 1 or semester 1 2021. 2022. So this is the subject of fluid mechanics KEJ3104, especially for K2. This is the introduction to the course, and I'll cover for the topic 1 for the today. And before we go to topic 1, I'm going to give a little bit introduction to the course. Right? So this is the structure that basically the topics that are going to be covered in this semester, not in this semester, in this subject. I'm sorry. So we have 6 topics in general, but I think I'm going to be teaching for the first part for the topic 1, 2, and 3, and the second part going to be taught by Dr. Sani Goh, if you know him. It depends. Some of maybe teach topic 1 for 2 weeks, or topic 4 might be divide this topic into more section. But basically, this is the main topics going to be covered, where I'm going to teach the introduction and basic concept of fluid mechanics, properties of fluid, and of course, because we are learning about fluid mechanics, before we learn about the fluid itself, we need to learn about the properties, characterize what is fluid, how it gonna move, something like that. And the pressure and fluid static. Why fluid static? Because we also have fluid flow. Before we go to that deep, we gonna teach you about the static, that which is not moving in the beginning at first. Thank you. Right, so let's go to the assessment. So the assessment is going to be cover about 1, 2, 3, 4, 5, 6, 7 assessment type. Where you have seen here, we have quiz, test 1, test 2, lab report, and practical test and calculation assignments. Why you see here is quite a lot of assessments, 7. Even I think final examinations might be optional into continuous assessment, where we're gonna change it into 30 and 10 for test 3 or something like that. We're not set in stone yet. So that's why I put here assessment subject to change according to the current situations. Always check your Oceania or eLearn. Please check. We have put here the teaching and planning, teaching assessment planning for here for you to refer. If any amendments or update that we're gonna make, please have a look. Inshallah, we're gonna make sure to let you know in the group WhatsApp and everything. Okay, right. Okay, so why we have a lot assessments? Because fluid mechanics is a lot of familiar known to the students, even to the lecturer itself. It's quite fundamental subject. It's quite difficult subject, I can say. We make it this type, so you're gonna have a lot more assessments because we try to help you. For example, here final examination, if we make it 40% directly, if you don't study, you're gonna lose 40% direct way. But if we twist them a little bit into 2 kind of assessments, you might have a little more time to study. But the disadvantages of it, you have a lot assessments to cope on with other subject that you're gonna have. It's gonna be really hard. However, trust me, this is what we made here. We try to help you as much as we can. So your commitments and enjoy the study. We really need it. As long as we are together, follow the lecture, come to the quiz, take all the tests, insyaAllah. Nak bagi semua orang A, insyaAllah. I'm gladly given to everyone from my previous subject. Everybody is A's because everybody is giving their full attentions and commitments. All right. So let's go to the topic 1. Any questions you can ask me at the end of the question, at the end of the lecture, you can text, you can put in the WhatsApp and everything. Maybe you can ask Dr. Sani as well. Okay, the topic one is introduction and basic concepts of fluid mechanics. Of course, it has to be about fluid mechanics. It's not introduction and basic concepts about Instagram, TikTok, and everything. No, right? Okay, so this is the outline of the topic one. We're going to study about 15 things, but I put, because 15 sounds a lot, so I put a little bit things that you need to focus is in the red. I choose this because it represents the fluid mechanics concept and basic background informations about it. But I didn't say the other outlines, 1, 2, 3, 4, 5 here is not important. It is important, however, we would like to give more stress and emphasize on the red color over here. Okay, so the objective, of course, we want you to understand the basic concept of fluid mechanics. Of course, the concept first. What is fluid mechanics and everything? And because it's fluid flow, it has various types. So we want you to recognize. We want to recognize. And fluid mechanics is relatively, largely related to the engineering, technicals, field. So we want fluid mechanics, we want you to know, have a knowledge, working of accuracy and precision, of course, in calculations. Doesn't matter in engineering or not, but in calculations. That's why people who are graduate in not with fluid mechanics background, with technical backgrounds, companies such a bank, they want you because you are very precise, very accurate in your calculations. Trust me. Okay, why we study fluid? You can click here. You can click on the first one and the third one. You can see I have it here. So this is the a little bit introduction video. Okay, if you can see here on the right side here, people are commenting because in the video it says insane and extremely rare natural phenomenon, laminar flow. Why? Because it's not insane, it's not extremely rare. Because need the right conditions with the right flow, right viscosity and stuff that we're gonna learn in the properties of the fluid. It's not rare. It's not a natural. It's not a rare natural phenomenon. Okay, so that's why this kind of information is important for us to learn about fluid mechanics. All right. So that's the first one. A second video. Okay, so in this video, as you can see here, in the beginning, the bulb doesn't light up. It is because the water over here is considered as the ionized water. So there's no ion. So the electric cannot passing through, cannot travel, or what we call it conducting between. But once he added the salt, which is the ion, so the water become ionized again with the salt, and then using the ion, the charges can travel. It can be conducting now and light up the bulb. So that's the beauty of fluid mechanics. That's the beauty of the physics. Physics. See over here, it says that physics is fun. That's why I failed at physics exam. Okay. So it's fun, all right? So we're gonna try our best to make it. So if you wanna see more fun video about the fluid mechanics and physics, please follow the hashtag on the Instagram or whatever, or TikTok. You can see more relaxing real life example of fluid mechanics to get a little bit inspirations. Okay. Right, so this is another fact of fluid mechanics, why people learn about fluid mechanics, because certain fluid, when I say fluid, it can be water, it can be gas, it can be solid, it may be not solid. However, if we talk about fluid of liquid can be anything, water, bitumen, petrol, whatever you want to name it. So if you can see here, this is one of the longest lasting experiments. It was about 70 years between 1930 to the year of 2000, where it only 8 drops of bitumen, only 8 drop of oil actually fell. Because of what? Because the fluid is viscous. Okay, so this is the kind of properties, the stuff that we're going to learn in fluid mechanics that make a lot of different applications and everything. Okay, so why engineers, why environmental technologists are interested in fluid flow? If you can see here, somebody is working in the petrochemical industries. In the petrochemical industry, there's a lot of tubing, there's a lot of piping over here. This involves every part of here is fluid mechanics. Every part of this is fluid mechanics, trust me, because it involves a pressure, temperature. This is pressure, I'm sorry. Temperature is everywhere, and they got a joint where you got a pressure loss and everything. Everything is about fluid mechanics. Okay. Right, so this is the boring stuff that I'm going to show you. The subjects that require the basic fluid mechanics concept, where it covers everything, I can say. Semua benda lah, it covers everything. Groundwater flow for water supply, hydrology, because it's fluid. Hydrology is water, right? It's the water or wastewater or wetland water, budgeting and information, all needs fluid mechanics informations. Okay, even in medicine, you can see here, I can show you in medicine, in our hearts is fluid mechanics. There's a pressure in our aorta, there's a pressure in our vein, that what we call it as blood pressure and everything, that's pumping the blood around our, into our brain, into our small big brain, idiot brain and everything. So it's very important. Fluid mechanics is very wide applications. So as you can see here, because I just put a simple fancy a fancy photo for you to look around here. There's a power plants, natural flows. If we don't study fluid mechanics, it's gonna cost you a flood, flash flood. It's gonna cost you somebody that born without a proper and perfect lung or heart's gonna be suffer, or we may not even have a electric, because the power plants that we operate doesn't have any information on fluid mechanics. Okay. All right. So the first of all, what is fluid? What is fluid? Fluid is actually involved in solid or gas phase. This is fluid, not solid mechanics. Solid mechanics is a different level. Usually mechanical engineering students learn about solid mechanics. That is on different level. But for solids, it involves stress and strain. Stress and strain. This is one of the things and words that we always listen to in fluid mechanics. When a constant shear force is applied, a solid eventually stops deforming at some fixed strain angle, it's gonna stop. It's gonna stop deforming. All right. But this is solid. For fluid, it never stop deforming. It never stop deforming. Approaches and never approach a constant rate of strain. That's why, of course, if you choose a rubber for solid, when you stress or strain them, or you push them in every direction, if you have square rubber, you force any forces, any from above, below, right, and to the left, you gonna have some fixed strain angle, something like that. This is angle. Okay, forces acting on fluids. So actually, we consider fluids surface forces or stress. As you can see here, you can read by yourself. Surface forces are represented as the force F over A. F over A. What is this actually? It's actually pressure. F over A. Okay. So the figure shows over here the section of fluid surface can define in 3 dimensions: x, y, z. X, y, z of the fluid itself. Stress denoted as tau x for x directions, tau y for stress in y directions. You can see here x, y, and z. Okay, so if you want to know the stress in x direction, you have to consider the force in x direction as well. Okay. Okay, so the next one is the turbulence experiments. If you want to blame somebody why you need to learn about fluid mechanics, blame Reynolds. Reynolds is a person who actually the first one who studied and introduced what we call Reynolds number to characterize the type of turbulence and the fluid flow. Okay, what I mean by that is, okay, I'll show you later. So Reynolds established a certain conditions of, for example, the diameter of pipe, viscosity of the fluid, what else? The density, and also the fluid flow rate. So he come up with a Reynolds number. He calculate using a certain formula. He come up with a Reynolds number to say the water whether flow in lamina. Lamina ni dia macam tenang gitu. Lepas tu turbulence macam lah, macam kita naik kapal terbang, turbulence. Captain dalam kapal terbang kata, we are experiencing the turbulence because it's like orang kata apa, bergegar. That is turbulence. This is turbulence, what we call turbulence. Okay, so Reynolds ni dia study the number of dia study dan come up with a number. That's what we call it Reynolds number. Pada tahun 1883 lagi pada era zaman mungkin naiknya tamadun Eropah dan sebagainya lah. Maksudnya Reynolds ni daripada UK tak salah saya, if I'm not mistaken. So Reynolds demonstrated, this is the experiment yang dia buat. Pada mula-mula sekali dia buat, dia nak tengok benda tu bila dia lajukan, apabila dia guna liquid ataupun fluid yang lebih viscous, apa jadi? Adakah dia lamina, adakah dia viscous, adakah dia turbulence dan sebagainya lah. This is the person you want to blame why you need to study fluid mechanics lah. Okay, so this is Osborne Reynolds, the name. Anyway, I think this person, I can't remember his name. He's from University of Manchester. So this is the real equipments lah. From the photos here, you can see this is the real equipments of it. Okay. So when Reynolds study about the fluid mechanics, it starts by using the assumption of no slip conditions. What is no slip conditions? No slip is actually a fluid flow over a stationary surface comes to a complete stop at a surface because of the no slip condition. Tengok ni kat sini. Zero velocity. Kat sini velocity dia katalah 2 ms meter per second. Masih 2, mungkin 2, makin kurang 1.5, 1 sini bukan kosong. Ini adalah antara assumption yang berikan di dalam the no slip condition. Uniform, mula-mula dia uniform approach velocity, tapi dia berhenti dekat sini. Mula-mula ni start, this end. Okay, alright. So this is another thing is class of flow, inviscid flow. Jadi inviscid flow ni boleh tengoklah kat sini. It comes from the center over here and then it disperse here, disperse over there, and it has 3 2 only, inviscid flow and also viscous flow. Okay, you can Google what is viscous means. However, in fluid mechanics, regions of viscous flow is the one that next to the plate and both side. That is the viscous flow. In viscous, away from the plate, Okay, this is the flow. Alright, this is what I'm calling what I've been talking about just now about Reynolds, that I want you to blame Reynolds where I have to learn fluid mechanics. So Reynolds have come up with this RE, Reynolds number. This is the Reynolds equation. Okay, this is the density, this is the velocity, this is diameter, and this is the viscosity. Okay, for this, for water you have density of thousands. For volume, let's say you have a velocity of 1 meter per second. 1 meter per second times 1,000, and the size of the let's say the size of the diameter of the pipe. Okay, let's say we have, this is a pipe. So water air lalu, water coming through. So this is diameter about 1 meter. So the density is 1,000. So 1,000 times 1 meter per second of velocity times 1 meter. Let's say you have a viscosity of 1. So you have the Reynolds number of 1,000. So 1,000 is less than 2,000. It considered as lamina, yang tenang, slow. So this is lamina. And but if you have something, you increase, you use a different or you use a different velocity of water coming through inside the pipe, a tube here. Let's say you use 5 meter per second in 1 meter of pipe. So air yang keluar ni dia akan jadi turbulence. Jadi boleh tengok kat sini, air yang lamina, Reynolds number dia bawah 2,000, less than 2,000, it has smooth layer of fluid. However, for turbulence is disordered fluid motion. Dia haywire. High viscosity kebiasaannya lamina flow, usually they are high viscosity fluids. Low velocities, and for turbulence it can be low viscosity, but usually it high velocities. Depends because turbulence, why it has to be low viscosities as well? If it's high viscosity, it cannot move like the bitumen just now. It take 8 years to just have 8 drops. Okay, between 4,000 and 2,000 we have transitional flows that alternates between lamina and turbulence. Ada sikit-sikit lamina, ada sikit-sikit turbulence. Okay, we have also the steady and unsteady flow. The steady flow, it usually doesn't change at the point of time. Unsteady, it change. The flow always change. Steady and steady flow. We talk about flow now. Flow is not changing at the time. Okay, pukul 5 air tu steady je, air tenang, jangan disangka tiada buaya sebagai contoh lah. Unsteady, it change at a point with time. Okay, uniform, no change with time or locations. And the periodic, unsteady, oscillates. Sekejap dia uniform, sekejap dia steady, sekejap dia unsteady, for example lah. So benda-benda ni is very important. It depends on the application of the devices lah. Kalau steady flow such as turbines, compressor, it has to be steady, something like that. Okay, so flow, we have 1 dimension, 2 dimension, and 3 dimension. So if you can see here on the right side, on left side here is the 2 dimension, and then on the right hand side here is the 1 dimension. As you can see here, it has x and y. Here you only have maybe y only, you can say, okay, because it's only one dimension. Right, so the next one is the system and volume control. Okay, for the system and volume control, this is what we call it. They have a boundary that can be fixed or movable. Kat mana kebiasaan kita tengok benda ni? Biasanya kalau kita pergi bengkel, we went to the workshop, we have bengkel tu kebiasaannya ada satu mesin yang dia nak angkat kereta so they can change the engine oil. Jadi dia menggunakan konsep ni lah. Dia move. When they push here, it move this one. If this is connected. Okay. So this is the system lah. It can be closed or open. Kalau close, kalau dia bersambung in continuous, dia can move. Okay. Tengok Closed system ataupun control system is actually a fixed amount of mass. And no mass can cross its boundary lah. But energy can cross the boundary. Energy, yes. For example, when we hit this, so the gas expand. Energy go in, energy can go out. Okay. Okay, the next one is about dimensions and units. So dimension and units is actually concerned about discourse and quantify as main dimension. It's actually a dimension. Unit-unit yang kita ada ni actually a dimension. Like length. Length, unit dia apa? Meter, centimeter and stuff lah. Time, unit dia apa? Minute, hour, second and everything lah. Mass, kilogram, gram. Okay, when we go to the unit, sometimes because we have we gonna combine the dimension. For example, for work maksudnya force darab dengan apa ni? Darab dengan time ke day ke apalah. Okay, jadi force sama dengan M darab A. M ini adalah mass. Okay, mass M. Okay, A adalah acceleration. Acceleration sama dengan meter per second kan? Jadi meter per second per second. Meter adalah panjang ataupun length, L. Per second adalah time. Time per second. Ini kalau kita convert balik dia akan jadi M S negative 2. Okay? Sama juga SI unit. But the units also found in the text lah. Macam feet, apa lagi, untuk berat selalunya pakai pound. Itu antara yang bukan SI unit lah. Okay. Jadi benda-benda ni, all these things, units and dimension always appear for the pipe size. Selalu orang kata pipe 1 inci, pipe 2 inci, macam fluid volumes and everything we use in standard or non-standard unit. But usually in the market, it's quoted in standard units. Okay, you need to know how to convert the standard and non-standard units. Okay, the next one, before we end off the lecture for the topic 1 for today, is accuracy and precision. Ni dah belajar dalam fizik daripada form 5 lagi. Dah belajar dalam fizik. Okay, kalau yang A ni, dia adalah precise tapi tak accurate. Kenapa? Sepatutnya dia kena semua kat sini. Kalau semua kat situ, semua kat tengah ni, dia akan jadi precise and accurate. For shooter B, dia precise, bukan precise, dia lebih accurate sebab lebih dekat dengan target dia ni. Tapi dia less precise, dia tak bersama. Kat sini satu, sini satu, kurang precise. Okay, that's all. Thank you for watching. Next is the tutorial. Tutorial boleh buat dulu, you can do first and I'll give you the answer and we can discuss in the next session. Okay, thank you.